Hey guys, we've got a repair job to do on a shaft and a coupling out of a Cincinnati mill. These parts belong to Matthew Perlman, and you can check him out on YouTube. He's got a channel and he's got some videos on the Cincinnati milling machine that these parts go to. He's got one showing the teardown and explanation of what happened and why these parts need a repair. So go check him out on YouTube. He's got some other type of content on there, you know, shop related content, different projects that he gets into. But Matthew reached out and asked me if I would be interested in helping him with this repair. So I said, yep, I think we can handle that. So we went ahead and boxed it up and sent it down here. So what we have is this shaft right here. The fit here on the end is kind of galled, and the coupling here actually fits on this. And what Matt said is that he thinks that somebody previously went into this mill and took this apart, did something, and when they put it back together, they didn't actually tighten this coupling properly, because he found it loose whenever he took it apart. And so this has been wobbling on the shaft right there, causing wear inside of the coupling there. You might be able to look inside there and see, you know, all this galling in there from it kind of wobbling back and forth on the shaft. And it also stretched this keyway. This is a 3/16 wide keyway in there, so that's stretched out as well. So we have a bad bore there, bad keyway, and then the shaft fit here is kind of, you know, galled up there as well. So what we are going to do, I'll set this coupling up, and I think the simplest way to repair this is to go ahead and set this up true in the lathe, and we'll bore this ID to where it's just clean. Just skin it until it just cleans it up nicely. I'm hoping that it don't take more than, say, 10 thousandths to clean this up. All right, and then once we get this bored clean, I'm actually going to have to make a broach plug. We're going to make one that looks like this right here. This is a good one, 13/16 Dumont. So we're just going to copy like this style, and we'll make a broach plug, just machine one that fits this bore right here. And then we'll broach a 3/16 key opposite of the original here on the other side, and that'll allow it to have a nice key there. And then Matt said that he's going to do some calculations on this, and he will rebalance this on his end. You can see that Cincinnati did a good job on designing and building and machining this coupling. They've even got balanced stamped on there, and that's what these drilled holes are for, is the balancing holes. So Matt said that he is going to rebalance it because of the extra key in there, but it shouldn't be a problem to figure that out on his end. All right, so once we get this completed, I'll move on to the shaft, and what he would like me to do is do a flame spray buildup repair on this. So this is a heat treated and hardened shaft. I checked it over there on my hardness tester in a few places, and I was getting anywhere from 43 to 45 Rockwell on the end of this shaft right here. One of his big concerns with TIG welding this up is, you know, damaging the original temper, the heat treatment of this shaft right here, and weakening it anyway. So the flame spray process is a process that you can use that won't damage the heat treatment of a shaft, as long as you fall within the right parameters. You're not supposed to get it over 600 degrees whenever you're doing the flame spray. So that'll be a pretty good process. You know, I wasn't originally concerned about the keyway in here, but the flame spray buildup does work over keys as well. Okay, so that's the route that we're going to take, and I think it should be a solid repair. And then once this is back together, you know, this goes together, and when this is tightened down properly, that should never move. So this is another one of those cases where the other part, in this case being the coupling, is going to be captured around that flame spray buildup on this shaft right here. So it should not, you know, break out or fail in any way once this is tightened down on there. So that's the job at hand, and like I said, we'll go ahead and start the coupling. So we'll go on down to the lathe and get started boring this guy out. Before we go to the lathe to bore this out, what we need to do is install a shim in here, since this is a split coupling like that, and right now it is in the open, relaxed position. So what I've done is I found a piece. This is some stainless steel sheet metal right here, and it fits this slot nicely. It's 1/8 slot, fits in there nicely. And then we'll take that. I'll take and cut that piece out and dress it so that it doesn't stick out past the coupling there. And then we'll go ahead and tighten up the socket head bolt against the shim like that. And then once that's done, we'll go ahead and set it up in the lathe and then do our bore that way. I'm going to use my DeWalt bandsaw to cut this piece out right here. Also going to use a little bit of this anchor lube to lubricate the blade. I'm going to be using my TMX6 jaw to do this job, and I always keep this thing centered up. Anytime I remove it from the lathe and then put it back on, you have to recenter it. This is the set true style with the backing plate. So always just take one of my plug gauges, this being a 1-inch, and use that to do my indicating. And we'll go ahead and give it a check before we get started on this job. Now I do go around to all 3 of the pinions, which is what moves the scroll. And I just kind of evenly snug them all. It does help keep this thing centered. We'll just put an indicator on here and just give it a quick check and see what kind of run out we're getting. So that's no more than a 1/2 thousandth. So it looks like maybe 3 to 4 tenths on that indicator right there. So we're still good and centered right there. So we can rely on that to accurately hold our workpiece. I'd imagine this thing is not going to be, if you try to indicate this thing perfectly zero all the way around, it may be off slightly because of this thing being cut. You know, this may have moved a little bit after the original machining. So I'm just going to try to average it the best I can. That's looking pretty good. That's within 0.003 right there. Let's see if I can't get it any closer than that, and then we'll just roll with it. That's 0.002, so I keep improving it slightly. All right, well, you get the idea. I'm going to keep pecking at it there and trying to get this averaged out, you know, between 4 spots there as evenly as I can on the face. And our OD should be pretty good right where it's at. So I got it within 0.002. That's the best that I can do. And I think that 0.002 is just a unevenness of the face there because of the coupling being split and you know, being pulled on like that. So we're going to call the face good. I want to go ahead and move the indicator around here and just kind of give the outside a check and see how it's running as well. But it's not going to be perfectly round, the same thing, because it's split and this bolt is drawing this together. So you're going to have a little bit of difference there in your outside diameter as you roll across it. Let's see what we're looking at. That's going to be your low, and then your high is right about there. So we're looking at about 0.003 on the OD difference in roundness there. But I know the chuck has got this thing centered well, and it's going to be good right there where it's at. So we're going to call this indicated. We'll go ahead and set up. We're probably going to use a small carbide boring bar to go in here and bore this out. I'm going to use this Micro 100 Micro Quick system here to do the boring. So this is the carbide bar that we're going to use right here. It's specifically designed for their Micro Quick interchanging system there. All right, I did go over to the diamond wheel on my carbide grinder, and I touched up that radius there because I had used it on a previous job, and I could tell that edge, the top cutting edge there, was just slightly dull. So I just kind of radius that corner there. But they make these in different size shanks here. So this being the 1/2 inch, and I got a few different carbide bars with the 1/2 inch shank. And they do make a lot of different profiles. So they have different links here that you can do. They have internal threading and grooving tools as well. So that it's a really nifty little system, and they come tiny too. So I've got this in 1/2 inch and 3/8, and I believe they got them even smaller than that, the shank size. So there's a pin in here. You see this angle ground on the back of the bar. The bushing is clamped down on this flat in the tool holder here, so it's squared up there. And then when you put the shank in there and you push it back in, that pin through here lines the bar up here on the cutting edge. It lines that up level. So you can see it twisting as I go back in there with it. All right, and then you've got a set screw right here. All you do is just snug up that set screw. And they've got that set screw machined like on a cone point, and it engages that groove machined or ground into that carbide, and that's what locks it in. So locks it in tight and pushes it back at the same time. So there we go. That should work out pretty good. Okay, we are ready to get this coupling bored out, get that bore nice and clean. We're gonna run 700 RPM. We've got about a 5,000 feed rate. Trying to take the minimum amount that I can out of this. And come up and making sure my compound is locked. All right, so we're just touching the bore there. That's about 5,000ths on the dial. Run that through there and see how it looks. Yep, still got a little bit to go. Not quite cleaned up, but it's almost there. So that area right in there has got quite a bit of wallering still in there. This side is pretty well cleaned up. So we'll take another 5/1000 and see if that cleans it up. So there are still a few deeper galling marks still in there in that bore, but I think it's going to take quite a bit more to remove those. I'm thinking, 15-20 thousandths maybe to get rid of those gall marks. But we have a clean bore all the way through there. All the way through the other side, we got a nice clean bore area. It's just those little areas, those spots in there that I don't think that is going to hinder the performance of the bore tightening down properly the way that we want it there. So I believe I'm going to leave it right there where it's at. We'll go ahead and give this a measure and see where we're at on our dimensions. I don't want to go any larger than I have to because we're going to be doing a build-up on the shaft to meet the diameter. Usually when you do these flame spray buildups, you build it up and then you turn it back to the same size. In this case, we're going to be a little bit bigger. So I want to see where we're at. I'm using the Starrett number 204 mic. So it looks like we're right at the 765.765 inches is going to be our final dimension there. So 15 thousandths over your nominal 3/4 inch bore size right there. I'll go ahead and do it again just to kind of verify. I'm making sure that I'm not putting the fingers there of the telescope gauge in any kind of groove, any of those low galled spots. And we'll verify our measurement here. That feels good. Just touching there at 0.765 on the mic. So that's going to be our bore size. And we're going to leave it right there where it's at. And I think what we need to do is go ahead and put a nice little chamfer on this side as well. All right, that looks good. All right, our bore is now complete. All right, so we got our coupling bored. So the next step is to go ahead and we want to broach a new keyway in this. And I may have failed to show you this earlier. So that's the original Woodruff key that was in there. And you can tell by looking at the side just how bad that is worn, and it was rocking back and forth on that key. The coupling was. It was just shaking back and forth like that. So that keyway is pretty well stretched. I mean, let's get a little measurement there with the calipers. You can see, I mean, it's a good 10 thousandths over what it should be right there. So we're going to broach another key. All right, so as I had said before, all I have is the standard Dumont broach plugs like this. This is a 13/16, so it's slightly bigger, and a 3/4 is going to be too small. So I'm just going to machine one. We're just going to machine one to look just like that. This is a piece of stock that I have on the shelf. I don't remember what I had machined that for. I just can't remember, but it was a while back. Piece of stress proof, so it'll machine real easy. We'll just come down to this end that I machined that radius on, and we'll just turn one of those, the proper diameter to fit the bore, and we'll cut it off, and then we'll go to the milling machine and mill the proper slot right there. So I'm just going to use these factory made ones to get the proper depth and width for the broach. And then probably what I'll do is go ahead and flip it over onto this key once we get that finished, and we'll mill another key across the top so that when we stick it in there, we can actually line up the original keyway it'll be close enough, even though it's got a little wear. We'll be able to line this broach plug up, and it'll allow us to be exactly 180 degrees across to the other side of the coupling there, and then we'll broach our key. So this is the broach that we're going to use right here, the Dumont 3/16 broach with the one shim right there. All right, we got our broach plug cut off. I went ahead and faced it and chamfered it to clean it up. So we're going to go ahead and start our keyways now in here. Got it setting down on a parallel. I'm going to start with the 3/16 keyway side there as well. That way we can flip it over. I can put either a tool bit or a piece of key stock in there and flip it over and set it directly on that flat of the square, and then we'll mill the slot for the broach. Just going to use this 1/2-inch diameter edge finder to locate the center of the workpiece here. Just find one side right there, zero out the DRO, and I use the half command on it. So once we find this side, it's super easy. You just reach up and hit half, and then hit whatever direction you're going, and it splits it in half. So we hit half, Y, and then bring it right back to the 0 on the DRO right there. Get a flat established there with our end mill. Just take it until, yeah, just barely catch that diameter there. Go ahead and bring it up. So half of 3/16. All right, I've got the Noga Cool here that I'm going to use as well. I'll be able to just take something like this right here, this piece of high speed, 3/16, and we'll be able to set it right on top of that on our parallel upside down. All right, so I've got the tool bit pressed into that slot right there. It was a little snug right here where it went through that deeper section where it had to cut. So I just went over there to the little vise. I deburred it and then just kind of pressed it in there. So it's snug in there, not going to fall out, and I know it's going to be flat. So I'm having to go with a little bit shorter parallel, and we'll go ahead and make sure it's clean there. No chips in there. And we're going to take it and just set it right on that flat of that square tool bit. Push it up against the shoulder. That should be good, and that'll make it nearly perfect 180 degrees out. So we're already centered up on there. We don't have to recenter it. We just need to touch off and start making our cuts. So this is a lot deeper than a standard keyway right there, you can see. So I've already measured it. And what I usually do is just take the actual broach, in this case, our broach right here. And you measure, I'll just measure it with some calipers, or you can use a mic. Right before it's, our first cutting flute is right there. So if you measure it right there, let me see if I can do that for you so that you can see it. And it should give you kind of an idea of the depth that we need to be. So right around 370, 371 is going to be our depth of our slot right there. Our very first tooth, it's going to be a little bit bigger than that. See, around 377 if I can get it squared up. So it'll start cutting on that first tooth right there. I've got my flat established there. I'm going to go ahead and run it across by hand here and mill through that shoulder. Just like that, just so that when it comes through that area, it's not twice as depth and trying to deflect that cutter there. So 370 to 371 is our target depth. We'll probably just split that into 4 cuts, 100 thousandths, and then we'll finish off the last cut at 70 thousandths deep. That's our 3 passes right there, so we still got 1 more to do. I want to go ahead and check the depth there. So what I'll do, I've got this little fine triangular hone. I'm going to lay it right on top, just try to keep it flat, just like that. And just lightly hone that rolled up edge right there. Try not to take a bunch of metal off of it, but I just want it smooth there. And we're going to take a depth mic. So it should be 300 thousandths, and of course that was just by feel, getting the flat established with the cutter. Tight space in here. All right, let's see where we're at. Looks like we're at 200. I know you can't see that very well. It's 298 thousandths, so about 2 thousandths off. All right, one more depth cut, and then we'll have the bottom cut, and then we'll have to side cut each side there to kind of get it out to the proper width, because it's just over 3/16 on the width there. All right, that's 74 thousandths deep is what I took for that last cut there. See if we can get a little more air in there to blow those chips out. All right, it's not going to take much to widen this out. Grab my calipers over here, and it's measuring right around 190 on the width of the cutter here. 190. There's 191. See what I mean? Depends on how hard you squeeze the calipers, honestly. So. It's not going to take much, but we need to go in there and clean it up. So I'm going to offset it to each side like 1/1000ths, and then come down just each side and clean that up. Offset at 1/1000ths on the back side. Go down that side, and then we'll offset at 1/1000ths on this other side, and then clean that side up there too. And I'll just do that until I, just hand fit it until I know that the cutter goes in there. The important thing is you don't want to cut that slot real sloppy, because if this is too sloppy in that slot and it's trying to do this right there, you're going to have a really nasty looking keyway that you're broaching. I've experienced that before. I'm just going to go ahead and check it with the cutter here. It's trying to, so we've still got a little bit more to take out of there. So we're going to go 1/1000ths to the other side and clean that up. I went too far, so now I'm having to redo it again here. Let's see. There we go. All right, let's try that right there. All right, so if the cutter doesn't fit after this, I'll do the same thing. Just take another 1/2 off each side until we can get this cutter to fit in there properly. Working with the small stuff like this right here on something like this that isn't really super critical, you can just do a hand fit on it instead of trying to get in there with measuring tools and gauge blocks to try to measure it. But that's another way to measure these, is with gauge blocks. See, I still got a little bit more. It's kind of tapered in there, so I can't quite get it all the way to the bottom. So I need to make another cut down each side and open it up just a little bit more. All right, so what we did was we took 2/1000ths off each side, and now we've got the cutter. It actually got a nice fit down in the bottom of that slot right there. So that works pretty good. It looks like it's lining up right where I want it so that first tooth will start cutting. So we are there. All we got to do, I just need to do a little deburring on that. You can take this stone again and just do this right here. Just stone that sharp edge off of it. Do a little filing on the ends, and we'll be ready to broach a keyway. All right, there's our broach plug. Let's go ahead and get it installed. This key right there goes down and gets a little snug, which works in my favor. So just going to tap it in there like that. That'll keep it seated. Our broach goes in and stops at the first tooth, indicating I got the depth right, so that first tooth will be cutting. All right, so this is just a 2-pass broach, so we'll go to the manual arbor press and push the cutter all the way through there once, and then you go back in there one more time, you put a shim behind it, and you cut it one more time, and it'll be to the proper depth. All right, we're over here on the Greenard arbor press. We're going to use a little cutting oil on the cutter here. Put some on the cutter to help it kind of slide through there as well in that keyway slot. I guess I am going to have to. The end of that broach must be flared just a little bit. Have to use this punch to push it all the way through there. All right, there we go. All right, one pass down, one more to go. So what I did was I went ahead and removed the plug and I flipped it over to the opposite side there, because I realized it did what it typically tries to do. A lot of times these cutters, when you're trying to broach and you push it down through there, the bottom starts pulling, and so the teeth start digging in and cutting deeper at an angle as you try to get it down through there. That was one of those thick chips right there. I wasn't looking to the side to realize that it was trying to do that. So whenever it does that, I'll just flip it over upside down and then push the broach through the other direction to straighten it up, and then just try to work the cutter so that it doesn't try to kick out. A lot of times what I have to do whenever it tries to do that is reach underneath here. I'm kind of jammed into this little spot here against the wall. But a lot of times when I'm doing this, like this right here, we'll just go ahead and push it through there again so you can see. A lot of times I have to reach underneath here and push on the cutter, the bottom end, to kind of keep the bottom end pushed up against the back of the slot as I'm cutting it. There's one little work area that I'm not really happy with that I have set up, is the arbor press is just over here, kind of wedged in this little corner against the wall. I really don't have another good place for it though. All right, so now wipe all these chips off my fingers here. Now we'll go ahead and install our shim, and we're going to cut it again. Stick the shim in there. I usually stick the shim in first, and then the cutter, like so. You see how it goes in there because it's cut at an angle. So I'm going to try my best to not let it cut at an angle again, and just clean up the bottom of the keyway as we're cutting it right here. Let me check it, make sure it's not crooked there. You can pull it out and look, and you can see the cutter is against the shim. So it should be straight right there. Let's keep it pushed up against the bottom edge there. All right, that felt better that time. It didn't bind up on me. That should be good. Get our shim out of there. And we should have one successful 3/16 keyway broached in this hub now. Okay, our coupling is completed there, the repairs that we made on it. So we've got a nice, fresh, clean, straight bore through the center of it. And then we have our new keyway that we just broached, this guy right there. All finished up with the exception of loosening the cap head bolt there and taking the shim out. But I'm going to leave this in there until the shaft is done so that I can, you know, make sure I go in here and measure it and fit it properly like we need to do. So that part there is complete. So we're going to move on to the next part of the project. This will be a separate video. So we're going to repair the shaft that fits it. And as I said before, I'm going to do my flame spray buildup repair on this. So we'll go to the lathe, get it set up running true. I'll do all my prepping that I need to do, undercut it. We'll do a buildup on it using the flame spray and then machine it to match the new bore in the coupling right there. And once we do that, this job will be finished up. So hopefully we'll see you on the next video. And maybe you enjoyed this little project there, making our shop-made broach plug. And you know, what I showed you making a broach plug, this applies to really any bore that you need to do. If you don't have a broach plug for a specific bore, that's all you got to do. If you got one that you can copy the depth there, if you got, even if you just have the cutter, that's really all you need is just the cutter. Go off the width of it, and then the you know, the width of it on this side right there, and you can make your own broach plugs instead of buying one. But they are cheap enough that you can usually buy one. But when it comes to things like this, these custom sizes, that's really your best option, is just to go ahead and make one like I did right there. All right. So, all right, we'll see you on the next video when we get the shaft repaired.